Hello, everybody. I am Richard Heim at NOAA's National Centers for Environmental Information, and in my 15 minutes of fame, I will be talking about how we drought monitor authors use the soil moisture data to develop the US Drought Monitor Map. Next slide, please. And I'll be focusing on three parts in this presentation. I'll briefly be discussing what the US Drought Monitor is, how we put it together, and second, what data are used to prepare the US Drought Monitor, and briefly going through these two parts because I think most people on this webinar are familiar with the US Drought Monitor already. And then lastly, spend a little bit more time discussing how can soil moisture products best be used to feed the US Drought Monitor and some particular issues that I think are important as a Drought Monitor author. Next slide, please. Okay, what is the USDM and how is it done? It's a map and narrative depiction of current drought conditions. It's not a forecast. It is basically saying what the conditions are as of 12 Zulu time, Tuesday morning each week. Drought conditions are depicted in a percentile-based format. We have 4 drought categories, D1 to D4, and an abnormally dry category. And the percentiles reflect how the current drought conditions are related to the historical probability of occurrence, and you can see the percentiles there on the right. For example, a D2 severe drought, 6th to 10th percentile is a drought that occurs on average 1 year out of 10 years to 1 year out of 20 or so. So it's a reflection or a description of how rare the drought magnitude is. Next slide, please. It is produced weekly. It is what's called a composite drought product because we are integrating a gazillion things into it, dozens of drought indices, drought indicators, and data products. And we can actually end up looking at hundreds of individual maps each week. We also incorporate field observations and expert input from over 400 partners nationwide. I think that's probably over 600 now. I can never keep track of how many people are feeding into this. NDMC has a nice pie chart that identifies and breaks that down, our partners down. We do all of this in a 3-day window, Monday to Wednesday, and the little picture on the right is kind of how we feel at the end of Wednesday. Next slide, please. And this slide basically gives you a taste of some of the indicators and types of maps and types of data that we look at and categories of data. Of course, we'll be focusing on soil moisture in this talk, but it's a lot of stuff. A lot of these indicators and maps have different time scales associated with them. And of course, with soil moisture, you have different levels of depth in the ground. Next slide. There we go. No, go back, please. There we go. And we do all of this using what's called a convergence of evidence approach. And that is determining if the majority of the information is converging and telling the same story. Are all of these indicators saying the same thing? If not, are most of them saying the same thing? And what are they saying? How do we determine that DX? It's based upon this convergence of evidence approach. And that's a little bit of a subjective interpretation, which we try to standardize amongst the authors. Now, next slide, please. All right, soil moisture products. We utilized soil moisture data from a variety of sources, the 3 categories, which I believe were discussed in the first webinar: satellite-derived products, modeled products, and in situ observations from mesonets and national networks. And that's how I will be structuring the rest of these slides, or the next several slides. So next slide, please. This is an example of some of the satellite-derived soil moisture products that we use to prepare the US Drought Monitor Map. One thing we need to be aware of when we're looking at these things is the units may vary, the scale may vary, and the period of record these analyses are based on may vary. If you have a map that has a period of record of, say, 10 years, then the intensity of dryness in a particular area on that map may not reflect the same intensity of dryness that a product based upon 100 years of data would be. So we need to keep that in mind when we're integrating these products. And The bottom left is the NASA Sport soil moisture. That's just one level of about 4 different levels or depths of ground that we look at. And the crop chasma on the bottom right is a nice product that I think USDA is involved in preparing from satellite data. Next slide, please. Modeled soil moisture products are shown here. I like to look at as many of them as I can. And one thing I like to do is see what are they all saying? Are they all consistent? If they are, then I have a fairly good degree of confidence in what they're depicting. If one shows dryness and the other doesn't, or shows wetness, then I need to keep that in mind and maybe not put as much confidence in that particular region's soil moisture depiction on these particular maps. And most of these products have units that can be related to the US Drought Monitor Dx percentile categories, but some don't, so we have to keep that in mind. And again, we have to be aware of the period of record that these analyses are based upon. Same issue as the satellite products. The period of record may result in a drought intensity value on these maps, which may not reflect what it would be if it were based on 120 years of data. Next slide, please. And then there's the in situ soil moisture products. And this sample here shows the USDA topsoil moisture, and also on the left, upper left, the middle top is the National Soil Moisture Network, which is a contoured map based upon Mesonet soil moisture in situ data. The upper right is the Oklahoma Mesonet, which is really nice. I love their format. Bottom right is the USDA scan map, and the bottom left is from, I think I'm blanking on that. I think it's a Kansas Mesonet. But we need to be aware of what these things are, and we have to remember that in situ, especially Mesonet data, are point values. They reflect what the conditions are at that point. A mile away, it may be different. Next slide, please. So how can soil moisture products best be used to feed the US Drought Monitor? 3 things I have here in the bullets. Soil moisture data should be presented in units that are related to the USDM Dx categories. That is crucial for a US Drought Monitor author. The second is display the data in a graphical or map form that is easily digestible at a quick glance. Remember, we have 3 days to look at this. We have hundreds of maps and products that we're looking at. We can't spend a lot of time on any individual one. And ideally, provide the soil moisture data in a GIS format, which can be imported into the ArcMap MXD. We use ArcGIS, ArcMap software to prepare this US Drought Monitor map by hand. So those are very important things, which I'll go through in a little bit more detail in the next slides. And next slide, please. So units that are relatable to US Drought Monitor Dx categories. Percentiles based on a long period of record at the station are the preferred units that we prefer as Drought Monitor authors, since they can be directly translated to a DX category. If that's not available, if you can't do it that way, then present the soil moisture data as anomalies from some base period means, so we know if it's wetter than normal or drier than normal. That does give us some information which we can use to make some determination of the DX category should be. If that's not available, then anomalies that are meaningful to a crop or other plant. If the soil moisture is not sufficient to meet the crop's needs or the plant's needs, then that tells us that you probably have a drought problem. So we need to be careful. We really need to be cognizant of what the units are that are used to depict the soil moisture data. Next slide, please. Here are some examples. And as soon as here they come. The bottom left, the top left is plant available water. Bottom left is fractional water index, and right is volumetric water content. As a drought monitor author who is not an expert in soil moisture, soil science, what are these? And how do we relate these particular units to the drought monitor category? I don't know. But on the two left maps, you see some color shading. It looks like Oklahoma Messenet folks are trying to relate these particular units to a wet or dry category, and that's helpful. Another thing I wanted to note is, and I think I'll repeat this in another slide, is on the left, these are point values, but they have some kind of contouring to show us the geographical pattern of dryness or wetness on these maps. Next slide, please. Okay, display the data in a graphical map or map form that is easily digestible at a quick glance. So this is basically, we want to see what the data are, the anomalies, soil moisture anomalies are geographically. And these are, of course, the current conditions. So seeing the geographical pattern of soil moisture conditions facilitates the creation of the US Drought Monitor Map. Remember, we don't have much time, and we really want to be able to just look quickly at the map and then be able to make some determination of how we should draw that DX line on the US Drought Monitor Map. Showing a time series graph of one station, multiple depths over time gives an idea of what is happening at that station, but US Drought Monitor authors don't have the time to look at hundreds of graphs or even dozens of graphs. It's nice, but those types of graphs are not that useful for a US Drought Monitor author. Next slide, please. I think I have some examples. Okay, here is an example of a time series. This is great for someone who is focusing in on that particular point, and that is the extent of their interest. But again, it's for only one station. And again, as authors, we just don't have the time to examine dozens or hundreds of these individual point time series graphs in 2 to 3 days. And also keeping that track in your head to figure out how should you draw it on the map. It's difficult, so we prefer maps. Next slide, please. All right, maps are always better. But again, what are percent of saturation, volumetric water content, and how are they related to USDM Dx categories? So we emphasize maps, emphasize units, and notice these are, again, point values on this particular example, Kansas Messenet. Good information. I see there's trying to be a little bit of shading there, which is helpful. Next slide. Provide the data in a GIS format that can be imported into our ArcMap MXD. Now, the US Drought Monitor map is prepared in an ArcGIS environment using the ArcMap software. Every one of those lines you see on the right is drawn by hand. The data layers can be imported and overlain on the US Drought Monitor map for accurate drawing of the DX. And it's kind of hard to see what I have here. That's probably an SPI, or I can't tell on my screen what that is. But the shaded stuff, the greens and oranges and blues, are a particular particular drought indicator. And having it there overlaid as an ArcGIS layer in ArcMap helps us better draw where the line should be, just kind of move the lines over the particular intensity of shading. So providing the soil moisture data in a GIS format that can be imported into ArcMap, such as a shapefile, would be ideal. There are other formats, such as TIFFs and so on, which is, I'm not a GIS expert or IT expert, so I blank on all the specific details, but there are other ways that soil moisture can be imported into an ArcGIS environment format in an ArcMap product. And I think that's the last slide. You can go to the next. So that completes my presentation. Thank you.